Hi everybody, thank you for joining us today at our SFI Curious Mind Centre here in Lismore, County Waterford, the birthplace of Robert Boyle. I'm Roseanne.
And I'm Sheena.
And we're going to find out a little bit about vacuums today, so I'm going to go and set up some cool experiments. What are you going to do, Sheena?
Well, while you're doing that, I'm hoping that we're going to meet someone very special. You ready?
Yeah, let's go.
Now it's time to meet our very special guest. We're hoping to call on the ghost of Robert Boyle. Robert! 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 Oh my God, you scared me.
Good morning. I am Robert William Boyle, and I'm dead, I imagine, which is fair. I was alive a long time ago, many moons before anyone had a telephone, television, or aeroplane. Fascinating things. I was a famous inventor, philosopher, and more importantly, a scientist, mainly working in the areas of chemistry and physics.
That's very interesting. Now, you have a very famous gas law named after you, Boyle's Law. Can you tell everyone what that's about?
Ah, yes, my law. I'm very proud of it. It's still used today, you know. Essentially, the law is a gas's pressure and volume are inversely proportional or oppositely proportional to each other. Think of a wobbly balloon skimming on the surface of the ocean. As you bring it or dive down under the water, the pressure increases and the balloon gets smaller, i.e. the volume decreases. So pressure goes up and volume goes down. Similarly, bring that balloon up high in the sky, pressure decreases, and the balloon will expand. Simply elegant explanation. You're welcome.
That is very interesting. We're going to be doing some fun experiments on that very shortly. But what I'd like to know first is, how did you discover this?
I used a J-shaped tube partially filled with mercury. By adding more mercury, I increased the pressure on the gas trapped at the end. I then observed that the volume of gas decreased as the pressure increased, and vice versa. From these experiments, I formulated Boyle's Law. And you're welcome.
That was so interesting. Thank you so much for your time, Robert.
I'm always ghosting about in good spirits, but for all of you out there, I've seen the work that you've been doing through the year, and you're all fabulously curious, a stupendous quality to have. Keep it up. Keep the work going, and you never know. You may have a law named after you one day.
Bye.
Sheena, you're back.
I am. I was just with Robert.
How is he?
He was telling me about all his vacuum pump experiments.
Oh, that's what I've been setting up while you were gone. What we have is a chamber, and what does it look like to you is inside the chamber?
Air.
Air, very good.
Yeah.
So we're going to pump the air out of the jar, okay? And when we do, then what do you think is in the jar?
Nothing.
And when there's nothing, that's called a vacuum. And that's the experiments that Boyle did.
We get going?
Put some stuff into it?
Yeah.
Okay, we're going to start with Bob, I think. Bob is an astronaut, and Bob forgot to put his helmet on, and he went to space. So we're going to put Bob into our pump, okay? I'm going to close the top. As the air gets taken out of the jar, what do you think is going to happen to the air that's in Bob's head?
He might get smaller.
Will we see?
Let's try.
Cool. Right, so the air is being taken out of the jar.
He's getting bigger.
So there's less pressure on Bob's head. So the air molecules that are inside of the balloon are getting bigger to fill the space.
So is this what all astronauts' heads would look like in space?
No, their heads don't usually expand because they're wearing a helmet. So Bob is getting bigger and bigger. So we're going to turn off the pump. So as I put the air in, the pressure inside increases, so the volume decreases again and goes back to normal. So we should try some water, try a liquid.
Okay.
Okay, so we have some water here. So I'm going to put some colour into the water just so that we can see a little bit better what happens. And if you just open the lid.
I will.
Thank you. I'm going to put our liquid inside. Now, I'm going to make a vacuum inside of the jar. So there's no longer going to be air inside the jar. So the volume of the water should increase if it acted like our balloon. Okay?
Okay.
So when a water molecule starts to increase, it turns into gas. So the water is going to start to boil. We don't need to give it any heat. It's going to boil at room temperature because it doesn't have the pressure of the atmosphere on top. Okay?
So if you were to go higher on the earth, like up a mountain,
yeah.
this would
so
happen?
people on top of Mount Everest can make tea at much lower temperatures than we can. If we turn off the pump,
yeah.
all right, our water's after boiling. Now, you wouldn't really want to touch what's inside that beaker, would you?
No.
No, because your brain sees bubbles, so it tells you that it's
Hot.
Very good. So we'll put the air back in really slowly. Oh, a bit of a splash. Do you want to put your finger in and see?
Yeah. Oh, it's still cold.
So when you decrease the pressure on a liquid, it's able to boil at much lower temperatures. So as you decrease the pressure, the volume increases. And that's what Robert Boyle was talking about. So that's all the experiments we have today to put into our vacuum pump. But you can see examples of Boyle's law in things like aeroplanes, deep sea diving, and even space exploration.
Isn't it incredible that Boyle's law came from someone who was born right here in Lismore in County Waterford?
Yeah, so maybe someday you could come and visit us here to find out more about Robert Boyle.
Or we can visit your school to do a mobile science workshop.
Yeah, so we hope to see you very soon, and thank you so much for joining us today. So bye.
Bye.